Welcome back to our second day of section 6.3, where we will continue to talk about and introduce you to this idea of logarithms. Today we're going to talk about these special types of logarithms called the common logarithm and the natural logarithm. And then we're going to get into solving equations with logarithms and ultimately use logarithms to solve problems. So before we begin, just a quick warm-up so that we make sure we remember the conversion. Take a second, pause the video, and write the logarithmic form of 1/3 to the -3 equals 27. Hopefully you got log base 1/3 of 27 equals -3. Okay, remember the base stays the base. The exponent is the answer in log form. All right, so today, like I said, we're going to talk about these two special logs, the common log and the natural log. The base 10 logarithm is called the common logarithm and is written as just log of x. Notice there's no base. Sometimes when I talk about the common log and the natural log, it's similar to like a square root. Oftentimes I feel like mathematicians just think about the most common things we use and then they take something away. We don't put a 2 in a square root because it's the one we use most frequently. Similarly, the common log, base 10 log, is the most common used, so we just write it as log of x. Therefore, if you ever see a log without a base, that's implied that the base is 10. Now, there's a second special logarithm. This one is a log base e. We learned about the number e in our last section, and we used it when we were talking about continuously compounding interest, the PERT formula. Having said that, when we start to see e's in problems, we can use another special log called the natural logarithm. The natural log is written as the ln of x, so it doesn't even say log anymore. It technically is the same as log base e of x, okay? So this is what it is, but we never actually write log base e of x. If it is a log base e, we write it as ln x, okay? So the expressions log base 10 of x and log of x mean the same thing, as do ln base e of x and ln of x, okay? So those are the same thing, but again, this is how you would see it. Now you'll also note that your calculator has these two special buttons on it. So on any scientific or your graphing calculator, you should see an logx button and an ln button, okay? So a log button and a natural log button. So if you have something that looks like this, we are going to evaluate these common and natural logs, but these ones we're going to use our calculator. Sometimes we'll do them by hand, but we're going to see how we can use our calculator. So I'm going to go to my calculator in just a second here, and I'm going to type in log of 900, then natural log of e, and natural log of -1.87. Now, it's telling me to round to the 10,000ths. Okay, just so we know the 10,000ths is going to be 4 decimals. Okay, so I'm going to round to 4 decimal places as I'm doing this. I'm going to pause and go to my... Here we go. So we need to be able to find the log button on our calculator. So if you're using the 84, you'll see on the far left-hand column, you see log, it's the 4th button up, and then the ln is right underneath. So the first problem we said we were going to do is the log of 900, or the common log of 900. See, when I hit the log button, there's no base. So again, that button is the common log button. I just typed log of 900, enter, and again, I was going to round to 4 decimal places, so 2.9542. Okay? The second example was natural log of e. Now, when I hit the natural log, the ln button, and then I hit the e, notice that e to the x is on the same button as natural log. Note also that 10 to the x is on the same button as log. It's because they're inverses. Remember, we already talked about that idea. Okay, so e to the x is here, so I have to hit second e to the x. Now, notice that it gives me an exponent because typically speaking, we always take e to a power. So in this case, since I just want the natural log of e, I'm going to put it to the first power. Oops, I'm going to have to delete that one. I need to get out of the exponent. There we go. Notice I get an answer of 1. Now, yesterday we talked about how if we have a base that matches this number, the exponent is the answer. Well, remember, we said that natural log is log base e. So this is log base e of e. So it makes sense then that the exponent is the answer. Now, the last one we wanted to do was the natural log of -1.87. Again, I actually didn't need a calculator for this because we talked about yesterday we can't take the log of negative numbers because no number to a power gives me a negative answer. So having said that, this is what you'll see on the 84. It says error, non-real answers. It kind of depends on the calculator exactly the error message they give you, but it is not possible. So you can see here I wrote down the answer we got for letter A. Letter B we got 1, but I did want to quickly show you, again, kind of what I talked about. Natural log of e is the same as log base e of e to the 1. If we think about what we did yesterday, we'd say e to what power equals e to the first. And so we can see that it's 1. So that one we could have evaluated without the calculator. Letter A I could not have. Now, similarly, if I see letter C, if I'm asked to do a natural log by hand, which we will at some point, natural log, remember that's base e to what power equals negative 1.87. And remember, e is 2 point something, so it's a positive number. Okay, so since e is a positive number, I can't take a positive number to an exponent and end up with a negative answer. So that's why it gave me that error. And remember, when I have that error, it's undefined. Okay, go ahead and pause the video, and I want you to try these 3 on your own. Okay, so type them into your calculator and find the answer. Once again, it wants to the nearest 10,000, so that's 4 decimals. Hopefully for log of 321, you got 2.5065. That's what I got anyways. When I typed in natural log of 1,215, I got 7.1025. And finally, when I typed in log of 0.17, I got negative 0.7696. So we can get negative answers. That happens sometimes. Remember, that's when you flip it. But again, because these are the common logs and the natural log, our calculator has that button. We can type them in. These would not have been ones we could have done by hand without a calculator. Okay, so that's evaluating the common log and the natural log. Those are calculator buttons. Now we're going to use these ideas that we've learned over today and yesterday, and now we're going to start solving equations, which is kind of where we started. We said we need to be able to solve for exponents, but we didn't have a skill to do that yet. Now we do. When I look at letter A, and I get 25 equals 10 to the x minus 2, as soon as I have to solve for an exponent, I am now going to use the idea of logs. I'm going to convert this to log form. So when I convert this to log form, I would say log base, my base is 10. Now, I don't need to write that 10 there. I like to put it in when I'm writing this out just because it helps me see it better. But log base 10 of 25 of the answer equals, and remember, the exponent ends up by itself. That's why using the inverse works to solve these, because it gets the exponent on a side by itself. Well, now I have log base 10, which is just the common log. I won't keep writing that. I just do it when I'm converting, equals x minus 1. Well, if I want to get x by itself, I would just add 1 to both sides. Now, I could put plus 1 on the end. Usually, I would do it as 1 plus log of 25, only because when I type it into my calculator, I need to be careful. If you want to, you could put the plus 1 on the end, but then you would have to make sure you keep your 25 by itself in parentheses. Let's go to the calculator and see how we can type this. Now that I did the hard work by hand, in my calculator, I showed it as 1 plus, and then it's the common log, 25. Now notice that when you hit the log, it automatically gives you a parenthesis. So now I just close my parenthesis and I hit enter. And I can see that my answer, it asks me to round to the nearest thousand, so that's 3 decimal places. So I would put 2.398. The 7 would go up to an 8. So 2.398 is my answer. Now, I just want to show you what I was talking about with the adding the 1. If I wanted to put the plus 1 on the end like I do normally, I would do log 25, but I have to make sure I close the parenthesis because I'm just taking the log of 25 and then I'm adding 1. You can see in that case I get the same thing. The reason I like to put the 1 in front is because if you forget to close your parenthesis and you do this, it's actually going to read it as the log of 26 because it's going to do the order of operations. It's going to simplify inside parentheses first and then and then take the log of it. Okay, so if I forget to do the closing parentheses specifically after the 25, that's what it would do. If I would have remembered to put it after the 1, so if you accidentally did this, it's for sure going to do the 25 plus 1. Most often, though, if you put it on the end, you would forget the first parenthesis around the 25. So that's why for me, I always like to put the 1 plus or anything I'm adding or subtracting in front because it makes it so that I don't make that mistake. All right, so 2.397, or sorry, 2.398 is our answer. So now that we finished letter A, it gave us exponential form, and then we solved and got an answer. Now we're going to look at B. Now in B, it gives us the natural log of 2x plus 3 equals 4. This time, it gives us the log form, but it wants us to solve for an x of what we're taking the log of. That's a problem. But we have this idea where we can now convert back and forth. If we're given an exponential, we want to solve for the exponent, we convert to logs. If you're given log form and you want to solve for a variable inside those parentheses for what you're taking the log of, then you're going to convert it to exponential form. Now, as soon as I see natural log, I need my base because my base is the same. Natural log means it has a base e. So e to the 4th power equals 2x plus 3. Because what you're taking the log of ends up by itself on the other side when you convert to exponential. Now, there's two different ways you could do this. You could type e to the 4th into your calculator right now and turn it into a decimal. And that's what the book does for the most part. You are free to do that. I'm going to go through this example and show you how you could do all of your math first. So I would subtract 3. I get e to the 4th minus 3 equals 2x. And then I would divide by 2. I'm allowed to type all of this into my calculator in one shot. I do have to put parentheses around the stuff on top. So I'm going to do that this time. But again, if you typed e to the 4th in your calculator, got a decimal, just make sure you round to quite a few decimal places as you do the rest of the math so you have the most accurate answer. So first I need to put my parenthesis. If I don't put this parenthesis, that's going to be a problem. So I do e to the 4th. I'm in the exponent. I have to get out. So right arrow key, minus 3. That was the top of my fraction. So I have to put all of that in parentheses so that the calculator knows to do that first. And then I'm going to divide all of that by 2. Again, if I didn't put those parentheses around, it would actually do the 3 divided by 2 first because division comes before subtraction in order of operations. All right, when I did this, I got 25.799. So we can type that all in together and then do that. Again, the other option would have been you could have just done e to the 4th. You get a decimal. But when you get this decimal, make sure you round it to like 3 or 4 decimal places. But if I calculated that first and wrote it down, our next step was to subtract 3, and then we divided by 2. So you see that we get the same thing either way. Doesn't really matter, just make sure you keep a lot of decimals if you write this down on your paper. Okay, so as you can see, I wrote down our answer, 25.799. Okay, pause the video, try these two on your own. Don't forget to practice typing it into your calculator, and then unpause the video to see how you did. For letter A, you should have seen that it's base A. So since it's in log and I'm solving what I'm taking the log of, I need to convert to exponential. Since the base is, there is no base, it's base 10 to the 2nd power equals 3x minus 2. This one I don't need a calculator for too much. 10 squared I know is 100. I would add 2. 102 equals 3x. You might need a calculator there, but I know that 102 divided by 3 is 34. So that one worked out nice and neat. Because there's no major decimals, we could have done that without a calculator. The second one, I'm solving for an exponent, so I know I need to convert it to logs. I would write it as log base e, and as soon as I say log base e, I know that's just natural log of 8 equals x plus 2. Subtract 2, and again, when I typed it into my calculator, I did a negative 2 plus natural log of 8, or you could have done natural log, but make sure you close the parentheses around the 8 if you want to do that. Any which way, check to make sure that you got the answer 0.079. And if you didn't, go back and double check how you typed it in. Make sure you type it in accurately. Okay, last but not least, let's do some word problems with this. Using logarithms to solve problems. The seismic energy x in joules can be estimated based on the magnitude m of an earthquake by the formula x equals 10 to the 1.5 m plus 12. So they give us that formula. We want to know what is the magnitude of an earthquake with a seismic energy of 4.2 times 10 to the 20 joules. So they're giving us an x value. So if I'm going to solve this algebraically, I'm going to substitute that for x. So I'm going to do 4.2 times 10 to the 20 equals this side of the equation, 10 to the 1.5 m plus 12. Now before today, I would have almost cried if I saw this because I have no idea what to do with it. It's big, it's ugly, it's messy, plus I'm solving for something in an exponent. However, now as soon as I hear I'm solving for an exponent, I'm thinking logs, because that is the inverse of exponentials. It allows me to get that exponent by itself. So I rewrite this in log form, but again, focusing on this side in log form because that's where the variable is in the exponent. So if I'm doing a log of the base is 10. So it's the common log, base 10. I'm going to write it as that now, of the other side. So 4.2 times 10 to the 20 equals that exponent, 1.5m plus 12. Okay, now this would all be in parentheses right there, everything I'm taking the log of. Now again, I could subtract 12. I get negative 12 plus log base 10, so just the common log of 4.2 times 10 to the 20th equals 1.5m, and then I can divide by 1.5. I could type all that into my calculator. Or when I got here, when I got to the common log of 4.2 times 10 to the 20th equals 1.5m plus 12, I could type this into my calculator and get a decimal. And if I type this into my calculator and get a decimal, I'm going to get 20.623. I'm going to show you the math first, and then I'm going to show you the calculator. And then I would subtract 12 from that. Again, most students prefer to do it this way in the end because you're working with just numbers then, and it looks less messy. 8.623 equals 1.5m divided by 1.5. So when I did it, I got m equals 5.75. And what we're going to see is when I type this whole big ugly thing into my calculator in one shot, I also get 5.75. So either way, my answer for this one is that the magnitude of the earthquake given this scenario is 5.75. All right, I'm going to go back to my calculator and show you one more time how to type this in, and then I'll have you do an example. First, if I want to type this in a really long way, again, everything on top has to be in parentheses. So I would parentheses, and I had the negative 12 in front so I don't make the mistake, plus log. It gives me the parentheses of what I'm taking a log of, and it was 4.2 times 10 to the 20th. And now here's where you have to be careful. Right arrow key, because I need to get out of the exponent. I need to close the parenthesis. That closes the parenthesis of what I'm taking the log of. But I'm also done typing everything on top, so I need another parenthesis. And then I would divide by 1.5. So the more comfortable you get with your order of operations in your calculator, you could just type all of that in. And you get 5.75 if we round to 2 decimal places. Now what I showed you is that, or you could on the very front end just type in that log of 4.2 times 10 to the 20th. There's less places to make typos in your calculator if you do these one step at a time. Oh, I did that again. Okay, so then you can see where I got that 20.623 that I had written down. And again, then we subtracted 12 from both sides. We did that by hand, and then we divided by 1.5. So again, we get the same answer both ways. It's just a personal preference if you like to get this decimal first. Again, most students prefer to do that. Last but not least, please read this problem and try it on your own. Pause the video and then unpause to check your work. All right, for this one, same setup, except 1.8 times 10 to the 23 is what they give me. That still equals 10 to the 1.5m plus 12. So this time I did choose to just, oh, not yet, sorry. Okay, so I need to solve for an exponent. I convert it to log, so log base 10. Don't need to put the 10 of this side. So 1.8 times 10 to the 23 equals the exponent, 1.5m plus 12. This time I type this into my calculator. Obviously without the 10, I don't need that. Log of 1.8 times 10 to the 23 gave me 23.255. Hopefully you were able to get that as well. Again, if you made a mistake on that, double check your calculating. Subtracted 12, I got 11.255. Equals 1.5m divided by 1.5. I got m equals 7.5 is the magnitude. Hopefully you were able to get that as well. Okay, so that's the end of our section. Again, we were introduced to logarithms. We'll continue to work with these throughout the chapter. But again, the advantage of logarithms is it now gives us a situation where we can solve algebraically for exponents, which before today we weren't able to do. Go ahead and work on your 6-3 day 2 Pearson practice. Thank you.